The diagram shows a circle, centre O, of radius r centimetres and a chord AB. Angle AOB is theta radians. The length of the major arc AB is 5 times the length of the minor arc AB. So in other words, this bit all the way around here is 10 pi. We know that L is equal to r theta. Anyway, we're asked to find the value of theta and of r. So, well, this angle here is 2 pi take away theta because it's 2 pi all the way around. So we know that r, 2 pi take away theta, is going to be 5 times r theta. This one here is just r theta, and this one all the way around, so all the way around here, is 5 times that. So r's can cancel, and we've got 2 pi take away theta equals 5 theta. So 6 theta equals 2 pi. And then theta is 2 pi divided by 6, which is pi divided by 3. And then if we substitute back, no, let's just use the fact that L is equal to r theta. So we've got 2 pi is equal to r times pi by 3. And the pi's will cancel off there, and that gives us r equals 6. So theta is pi by 3, r is 6. So now we want to calculate the exact perimeter of the shaded segment. So the perimeter is going to be around the 10 pi and then along the chord here. And to get at that chord, we could use trigonometry. We know this is pi by 3. We could split it in half and use just ordinary right angle triangle trigonometry, or we could use the cosine rule. Let's call this x. So x squared is going to be 6 squared plus 6 squared minus 2 times 6 times 6 times cos pi by 3. Cos pi by 3 is a half, so it will cancel with that 2. So we've got 6 squared plus 6 squared minus 6 squared, which is 6 squared, which is 36. And therefore x equals 6. So the perimeter is going to be 10 pi plus 6 centimeters. So that's that. Calculate the exact area of the shaded segment. There's various ways we could go about that. What I'm going to do is the whole circle, and then I'm going to chop off the little segment there. So the area is going to be pi times 6 squared, which is the whole circle. Then I'm going to take off the little segment, which I'm going to do by doing the sector, take away the triangle. So for the sector, we're in radians, so it's a half multiplied by r squared multiplied by the angle. And then we know for a triangle, it's a half AB sine C, and using that I'm going to get a half times 6 squared times the sine of pi by 3. And we want exact, so not a calculator job. So it's 36 pi, take away, so what's this going to be? So 36 divided by 2 is 18, divided by 3 is, so that's going to be 6 pi. And then 36 divided by 2, so that's going to be 18 times the sine of pi by 3. So sine of 60 degrees is root 3 on 2. So it's going to be 36 pi, take away 6 pi, take away 9 root 3. So 36 pi, take away 6 pi, that's going to be 30 pi. And remember the minus minus here, so that's going to end up being plus 9 root 3. When we take it out of the brackets, and that will be in centimeters squared.